Hello everyone. Today I will work with you on the new theory, purchasing power parity or PPP. So let me tell you a story about a Big Mac. Assuming that in the world there is only one goods exchange, which is Big Mac, okay? I mean, I know it is unrealistic. So on the first day of 2018, we observed the price of Big Mac in two markets. One is Switzerland. The price is 6.35 Swiss francs, and in the US the price is $5, okay, for the same Big Mac. So it suggests that this amount of Swiss francs should be the same this amount of US dollar. In other words, 6.35 Swiss franc equal to $5. And we know the trick to get the exchange rate, right? We can divide both sides by 6.35 here, there. So on the left hand side, it turned into 1 Swiss francs. On the right hand side, it turned into the value in US dollar, right? Yep, so it is exchange rate at the beginning of 2018. And yes, it is a theoretical or hypothetical situation. Now, during the year of 2018, let's assume that the inflation in Switzerland is 6%, and in the US is 2.5%. So when there is inflation, what will happen to price? Clearly, price will increase by the inflation rate, right? So it means at the beginning, the price is 6.35, and now after a year with the inflation of 6%, so the new price will be in Swiss francs, it will be the original price 6.35 multiplied by 1 plus inflation rate. And the same thing in the US, initial price multiplied by 1 plus 2.5% inflation rate, right? And therefore we have a new equation because it is the same price for the Big Mac. I mean the price for the same Big Mac, right? So this amount should be the same, that amount. And yes, they are in two different currency, as you can see here. Okay? So now you can do the math, and you can divide both sides by this whole factor, 6.35 times 1 plus 6%. So on the right hand side, it will be 1. On the left hand side, it will be $5 times 1 plus 2.5% divided by the whole thing here. And you do the calculation, and I do it for you. We will see that at the end of 2018, the Swiss francs exchange rate should be $0.7614. Okay, so here is the rate at the beginning, and here is the rate at the end. In the middle, we have inflation, right? So it tells us a few things. So you connect those three pieces of information here. It tells us a few things. First of all, higher inflation make the currency weaker. And you can see here, in Switzerland, inflation is high. So the currency is losing value at home and also losing value in the foreign exchange market. And yes, it loses more value than the US dollar because in US, inflation is lower, just 2.5%. So let's see if the number tells the same story. At the beginning of the year, 1 Swiss francs is about 78 cents. And at the end of the year, it is only 76. And yes, Swiss francs depreciate. And it is consistent with the fact that high inflation occur in Switzerland, right? Yeah, so it is the idea behind purchasing power parity. It tells you that high inflation make the currency weaker. Low inflation make the currency stronger. So in this case, US dollar have low inflation, and that is why at the beginning you have to pay 78 cents for 1 Swiss francs, but at the end you only have to pay 76 cents, right? So US dollar getting stronger. That is the idea. Now let's see how we can derive the purchasing power parity. So Remember that the exchange rate we are interested in is the value of 1 Swiss francs in, say, US dollar. So you apply the formula to calculate the percentage change in Swiss francs, and we learn it from chapter 3. It equal to the end value divided by initial value minus 1, right? In this case, it is a value of Swiss francs at the end of 2018 divided by the value of Swiss franc at the beginning. And in the previous slide, I keep those formula, okay? The value at the end is that whole number. So you can check it here. It is a whole thing here. Okay, I just copy it and make it look a little bit better. Okay. And you divide by the initial value, which is 5 divided by 6.35. You can flip to the previous slide and you see it. It is the first exchange rate and minus 1. Okay, it is a formula. So we do something, you simplify it because it is a division here. So that one is gone. That one is gone. So basically, percentage change in Swiss francs equal to 1 plus 2.5% divided by 1 plus 6% minus 1. And we know what is 2.5 and what is 6, right? So instead of using number, we plug here 2.5% is inflation in the US and 6% is inflation in Switzerland. And it is a formula for the so-called purchasing power parity. It suggests that percentage change in the value of Swiss francs, and in this case against US dollar, equal to 1 plus inflation in the US, and I mean expected inflation in the US divided by 1 plus expected inflation in Switzerland. Now, why people introduce the concept of expected here? Okay. In the previous slide, we don't see any expected, right? Because I want to show you I want you to feel the actual story. However, in finance, people interested in like forward-looking, forecasting. So they say like right now, at the beginning of this year, we're thinking about how the value of a given currency change over time and how we can assess it. We think about, hey, what will be or what should be the inflation in the future? In other words, what is the expected inflation? If we can find the expected inflation, or if we can estimate the expected inflation, yes, we can estimate the percentage change. And it is the idea of purchasing power parity. Percentage change in Swiss francs equal to 1 plus the expected inflation in the US divided by 1 plus the expected inflation in Switzerland minus 1. Yep. Again, 2.5% here, 6% here. Yep. If you simplify it, I mean, we do a little bit manipulation and the formula look better. It tells us that the change in value of Swiss francs equal to inflation or expected inflation in the US minus the expected inflation in Swiss francs. In the book, it suggests you US as home, so you put inflation at home minus inflation in foreign country. Clearly, you may ask the question, what if we're talking about non-US dollar currency, right? So there is no concept of home or foreign, okay? So here's something I want you to pay strict attention to, because because you know that when it comes to exchange rate, we have currency A, we have currency B, okay? There is no home, there is no foreign. So how can I know that the order of the formula is correct, right? So first of all, pay attention to which currency you are measure. Over here, we look at the exchange rate or the value of 1 Swiss francs. Therefore, we calculate the change in the value of that Swiss francs. And it equal to the non-Swiss francs, which is US dollar, minus the Swiss francs. So that is the order you need to remember. Again, percentage change of the currency carry the value 1 approximately equal to the other currency, which is US dollar, minus that target currency, Swiss francs. If you want to do the exact formula, the same thing, you have to keep the, position, correct position. If you analyze the exchange rate of 1 Swiss francs and you want to estimate the change in the value of Swiss francs, the non-Swiss franc or US dollar or euro or Canadian dollar, anything non-Swiss franc stay in the numerator, okay? And Swiss franc stay in the denominator. If you change the position, we will get the wrong answer, clearly, right? Okay, let's look at some examples. The first one. So I make sure that we remember it, okay? So I keep the Swiss franc right here for you. So you have to preserve the position. I don't know if I stress enough or over enough for you, okay? But it is so important. We make mistake all the time. Suppose that the inflation in the US is expected to be 8%, and in Switzerland is expected to be 6%. What should happen to the value of Swiss francs? So again, the currency we get quote here. So first of all, what we know is very logical, right? Higher inflation in the US make US dollar depreciate, clearly. Lower inflation in Switzerland make the Swiss franc appreciate, right? Okay. Now let's apply the formula and calculate the percentage change of Swiss francs. So we know that percentage change, okay, here, percentage change in Swiss franc equal to expected inflation in the US, which is 8%, minus expected inflation in Switzerland, which is 6%, so 2%. What does this tell you? Okay, let me work on the exact formula. Okay, exact formula, you know, right? So the formula is right here. This one here. So we plug the number in. So the exact formula is an appreciation of 1.88%. So with estimate, it is an appreciation of 2%. So it's close enough. Okay. So it means that Swiss francs should appreciate by about 2%. By about 2% here. Okay. Or 1.8868% if you use exact formula. Example 2. So if the US inflation is expected to be 3% and the expected inflation in Canada is about 5.5%, what should happen to the value of, okay, over here, we look at the Canadian dollar, okay? So again, higher inflation in Canada will make Canadian dollar depreciate, and lower inflation will make US dollar appreciate, right? So we apply the formula, we have it. So percentage change in Canadian dollar equal to inflation in the US, 3% here, minus inflation in Canada, 5.5%. So it gives you negative 2.5. It means Canadian dollar dropped by about 2.5%. Yes, you can apply the exact formula. Yeah, you plug the number in, and yes, it gives you 2.369% versus 2.5. It is approximation. Oops, sorry. This one should be Canadian dollar. Should depreciate by 2.5%. Right? Okay. Let's look at the extension. Now we assume that today exchange rate is 1 Canadian dollar worth 1.1111 US dollar. So what should happen to the value of CAD 1 year from today, provided that the inflation in US is expected to be 3% and 5.5% in Canada? Okay. So from previous slide, we already estimate the percentage change of Canadian dollar, right? So we can apply this formula, future spot rate equal to today's spot rate, which is 1.1111 times 1 minus percentage change, which is 2.5. Okay, again 2.5 is coming from previous slide, we work on it. Okay, 2.5 here. Yep. So you can see that the future rate for Canadian dollar is about, or should be about, 1.0833 US dollar. So you can see that at the beginning, Canadian dollar worth 1.1111, right? And after a year, it dropped to 1.0833. So Canadian dollar depreciate as expected, and it is depreciate by about 2.5%. Okay. So let's look at the third example where there is no US dollar. So first of all, so let me read the problem. Okay. So if the expected inflation in euro is 1% and expected inflation in Canada is 5%, what should happen to the value of Canadian dollar versus euro? So the exchange rate we want to look at is 1 Canadian dollar in terms of euro, right? So you have to be careful again about the position of the currency. If you want to apply purchasing power parity, change in the currency rate quote, Canadian dollar here, approximately equal to the other currency inflation minus inflation in Canada. So now apply the formula. It will be euro inflation minus Canada inflation, which is negative 4%. It means Canadian dollar should drop 4%. Okay? Now you see that if you flip the position of 5 and 4, I mean 5 and 1, you get positive 4%, right? It suggests you appreciate. Now, even if you get the negative 4, but you apply the negative 4 to euro, it also wrong, which you may say like a euro depreciate by 4%. No, the answer, it is not the right answer. 4% here, the depreciation of 4% apply the Canadian dollar. Okay, so if you apply the exact formula, it is about 3.8% depreciation for Canadian dollar. Yep. Okay. So Canadian dollar should drop by about 4% from today's value of 85 cents, right? So what should be the value? At the end, it should be today's spot rate, which is 8.5. I'm sorry, 0.85 times 1 minus 4% depreciation. And you plug in and you do the math, and it tells you that at the end of the year, Canadian dollar worth 81.60. Yes, it dropped from 85.00, right? Yep. So, thank you. I hope it helped.